Hey there, it's Max again, and we're going to be going through exercise 2 for Unlink. This exercise builds off of the knowledge from the previous one. In the previous exercise, we exploited Unlink by using a use after free on the FD and BK. Now, the exploit method, in terms of using Unlink and the overriding the got entry, is all going to be the same. The main difference here is how we're going to trigger the consolidation process. In the previous exercise, we had a use after free that allowed us to edit the FD and the BK. However, we don't have that this time. You're going to have to figure out how to do this yourself this time. What I mean by that is we're going to abuse the ability of the prev and use bit. The prev and use bit actually determines whether the chunk below it is free or allocated. If it's 1, it's allocated. If it's free, it's 0. So if we set this to 0, then we can actually trick malloc into thinking that our chunk needs to be consolidated and freed. But in reality, it's actually not the case. That chunk's still being used, it's still allocated, and we're going to trick it to perform the unlink process when it shouldn't. So with that, we can start looking at the code. And you'll notice it looks extremely similar. In fact, if I didn't just tell you what's different, you probably wouldn't even notice. First, we have 3 chunks here. We're getting the shell code before, but now the only difference here is we're not calling free on unlinked chunk. And instead of writing 30 bytes or something, we're now writing hex 90. So writing hex 90 is the problem here. The chunk size is hex 80. And before you go, but Max, we actually allocate hex 90 when we do this. And that is true. So good job thinking that. But even though we're allocating hex 90, we actually start from an offset of hex 10. And so we're actually moved over a little bit. We don't use the full chunk because the prev size and size are going to be the first 16 bytes of it. So we have a buffer overflow that allows us to overwrite the prev size and size of unlinked chunk. And after that, we're calling free victim. And if we set this up correctly and the prev and use bit is not set, then it will try to consolidate behind us. So in the start.py file, a lot of the stuff's the same. Here we have the fake chunk information, which will want to be the got entry of puts and the shell code like before. So that should be all exactly the same. The main difference now is this buffer overflow section. For this, the fake chunk is we need to write some buffer. So we've already written the 10 bytes here, the 16 bytes for the FD and BK. So when we write more, we want to make sure we subtract that, which is what that hex 10 is for. And although you could make this be hex 90 and do another hex 10, I used to put hex 80 because it's simpler for me to think about. At that point, we're going to get to the the prev size and the size. And we need to make sure we set up all of that stuff correctly in order to perform the consolidation process. So those are the other to-dos. For the prev size, we just want to make sure we go back to the chunk below us. And then for the size, we want to make sure the prev and use bit's not set. And that is a valid chunk size. I think if it's not a valid chunk size, then it just crashes. So keep that in mind. So with that, good luck with it. Just remember, the prev and use bit needs to be set to 0, and everything else is going to be the same. So good luck.